Okay, this is not my normal recording setup, but here we go. We're going to look at improper integrals today. When do we need to look at improper integrals? Well, the answer is these are needed when the interval of integration is unbounded, which means that one of the bounds is at infinity, or when the integrand, the thing that you're integrating, is unbounded somewhere on the interval. So, a couple of examples of where this might come up. Say you were integrating some function from a to infinity. Well, the way that we're going to do this is we're going to integrate from a to b, and then take the limit of that as b goes to infinity. That's the simple little trick that we're going to play on a lot of functions today. The only thing is that you might have to do some limit problems. But we're not going to look at super challenging limits, and a lot of times you can figure those limits out in not necessarily analytical ways if you have to. Here's the second type of problem. Say we want to integrate from 0 to 1, 1 over square root x. Well, I know how to integrate 1 over square root x, but I can't evaluate that integral at 0 when I'm done. So what we're going to do instead is integrate from b to 1, and then take the limit as b goes to 0. Now we need to do that coming from the right, because 0 is our left-hand endpoint, so we're coming at the interval coming from the right towards that left-hand endpoint of our 0 to 1 interval that we had. So that would be how we could switch around and do this problem. Let's actually work a couple of these out. So we're looking here at the integral from 1 to infinity of x to the minus second dx. We're going to play the switcheroo game and integrate from 1 to b, and then take the limit as b goes to infinity. Well, the integral of x to the minus second is minus 1 over x. We're evaluating that from b to 1. So you end up with minus 1 over b plus 1. And you're doing that limit as b goes to infinity. Well, when b goes to infinity, minus 1 over b disappears. It goes to 0, and you're just left with 1. Next up, we're going to look at question number 11. On this one, we again have an unbounded interval. We're integrating from 0 to infinity, e to the minus 2x dx. We're going to change that infinity into a b. And we're going to do the limit as b goes to infinity of 0 to b, e to the minus 2x dx. Well, the integral of e to the minus 2x would be negative 1/2 e to the minus 2x. We're going to evaluate that from 0 to b and then take the limit. So if you do that from 0 to b, you get minus 1/2 e to the minus 2b plus 1/2 e to the 0. Well, e to the 0 is 1, so that second part of that value is 1/2. And now when you take the integral as b goes to infinity, if you think about what's happening here, you're going to have negative 1/2 e to the minus 2 times infinity. Well, that's just going to blow up. It's going to be to negative infinity. If you take a value to the negative infinity power, that's like taking 1 over e to the infinity. That's 1 over a giant number. That goes to 0. So this is just 1/2. Another example. Now we're going to switch to the other kind. This looks like a perfectly fine integral, the integral from 0 to pi over 2 of tangent of theta d theta. But the problem is that you can't evaluate that at pi over 2 because tangent has an asymptote there. So we're going to do instead the integral from 0 to b of tangent theta d theta. And then we're going to take the limit coming from the left, because pi over 2 is our right-hand endpoint of our interval of integration. Well, the integral of tangent theta is the natural log of the secant of theta. And that's evaluated from 0 to b. So that becomes the natural log of the secant of b minus the natural log of the secant of 0. Well, the secant at 0 is 1, and the natural log of 1 is 0, so that second part disappears. And the first part, secant of b, if you looked at a graph of secant, when you take the limit of that as b goes to pi over 2 coming from the left, secant of b is exploding up to infinity. And then the log of that is also going to go to infinity, so this integral actually diverges. The last one we're going to look at, we want to integrate from 1 to 2, 1 over square root x minus 1 dx. Well, again, the problem we have here is we could do that integral, but we couldn't plug in at 1 when we were done. So we're going to instead do the limit as c goes to 1 from the right of c to 2, 1 over square root x minus 1. Well, that integral is 2 square root x minus 1. We evaluate from 2 to c. If you plug in 2, you get 2 square root 1, which is just 2, and then minus 2 square root c minus 1. And we're taking the limit as c goes to 1 from the right. Well, you can just plug 1 in to find that value over there. So when you plug 1 in, you get 0 in this part, so this part goes to 0, and you just get 2 for the answer to the integral. Okay, that is it for now. Thanks.